Hey, what's going on, everyone? Tim Wheeler with codesnippet.io. Today, just going to be messing around with the OpenAI Images API. And so yesterday we did some work with the OpenAI Chat API, built a cool ChatGPT clone using the same AI models that ChatGPT itself uses. So today, let's dive into a little bit with the Images API. I haven't messed with it at all, so it'll just be experimenting and seeing if we can make something cool with it. And I'll probably ultimately turn this project into a blog post. So try to do that. Give different formats of the tutorials themselves. So just to start, I'll probably just use this project template. It's a very lightweight, vanilla JavaScript application, client and server architecture. So client is just all of our front end code, and the server is all of our back end code. So again, super lightweight, no frameworks necessary. Let's go ahead and just dive right in. Again, today just going to be doing a lot of experimentation. So let's see how it goes. So I'll start by just cloning this, and let's see. All right, so just to start, we can install our dependencies. So npm install. So we have a env file in this project. So if we list all the files, we see this .env.example. This is where we'll store like application secrets and stuff like that. We can circle back to this later, but we're going to need most likely the OpenAI API key. And for that, let's go ahead and hop over here. So just from OpenAI.com, I guess you would log in to OpenAI.com. So something like this. If you don't already have an account, just sign up with Google. And once you get logged in or registered, you can view your API keys. And for today, we can probably just, so I have some existing keys, so I'll just likely just create a new key. I'm going to do that off screen, but one of the things that we'll do, actually, I'll hold off on actually creating the API key. We won't need it right this second, but let's just look at the API reference here. So today, working with images. So it looks like just to actually create an image, and just to take a step back. So the images API, when given a prompt or an input image, the AI model will generate a new image. So there's a related guide here, and it provides 3 methods for interacting with images. So create an image from scratch based on a text prompt, creating edits of an existing image based on a new text prompt, or creating variations of an existing image. So there's this DALL-E preview app. And presumably we just give it some type of text prompt like we just read about, or we can upload an image, and it will basically give us a variation of whatever we upload. So I think for today, a cool little project we can hack on just to experiment with this API is let's go ahead and do this like kind of option 1. So where we're creating images from scratch based on a given text prompt. So I think that would be kind of cool to see what something like that looks like. And going back to the reference, so in the API reference images section here, we want to likely use, yeah, it's going to be this endpoint that we're going to use. So we're going to post to this endpoint, and it looks like it creates an image when given a prompt. So that sounds like exactly what we want. And you can see it's pretty lightweight spec. So we pass in a very minimal request object with a prompt with an n, so number of images to generate. So n is, in this case, they'd be generating 2 images, and we can see that value must be between 1 and 10. The actual size of the image, so we have 3 options, it looks like, and a couple other optional parameters like response format. So I guess we could return a URL to an image, and presumably that's hosted somewhere, or we can get this B64 JSON format. So we'll cross that bridge when we get there. We'll see what that looks like as we go, but let's just let's create a little application using this stuff. So all right, so I'm using the code snippet project template here again, so I will see if I can link that anywhere. I threw that in the stream chat, so anybody that wants to use this, feel free. It's open source. If there's ever anything that you wanted to add to it in terms of additions or even subtractions, feel free to put up a pull request. We'd love to see any suggestions that you might have. So with that said, let's hop in here. Let's go ahead and just edit this boilerplate. Well, I guess first things first. Let's just see what we're working with our boilerplate. All right, so if we ran npm install, let's just run it again, and then npm run dev will start up the server, so we can see we're listening on localhost 3000. So what does that look like? Okay, so the boilerplate itself, it's already wired up as a full stack application. Again, super minimal. But basically, you pass in some type of value to this input, and it goes to the back end. It sends this request here with your payload, which in my case, I put the name Tim. And the response comes back from the back end as this object containing a data key. And then it just basically has a string that says hello, and then whatever the value that the user inputted on the front end. So same here. So you can see that the actual like data changes depending on what we enter in here. So very lightweight springboard, more or less, for us to build full stack applications. And so let's go ahead and just start tweaking these. This is an endpoint. So we have this, we're using Express.js, and that's a really popular framework. So let's see what Express. Fast, unopinionated, minimalist web framework. And if you've built your own APIs in JavaScript, odds are you've used Express, or you've at least came across it once or twice. Just a few weekly downloads, only 29 million. So yeah, it's kind of wild. Very popular framework, and so we're making use of that today. It's going to make our project quite a bit easier. So before we even do that, maybe we can just mess around with the actual API itself in Insomnia. So Insomnia is a REST client. I use it here. It's insomnia.rest. I use this in my day-to-day at work, and I use it for all my side projects and all that. It's basically just a easy way to send API requests, so we don't have to send curl requests that would look much like this, though you could just send something like this right from your terminal. It's a little bit more user-friendly to use Insomnia. So let me make this a little bigger so we can see as we go. And so, all right, let's mess around with this layout. All right, so with the API that we're working with, it takes a post request to this endpoint. So in Insomnia, let's go ahead and add that. Let's just, let's add a new request, HTTP request. It's a post. We can see that here. And I can zoom in just a little bit. And let me, I don't know, I'm still pretty new with Twitch, so forgive me. But anyways, I will, I'm going to be taking this URL and then we're going to be adding this to, all right, I'll do it this way instead for right now, because this way I can shift the windows around a little bit easier. All right, so I'm creating a new request in Insomnia, and ultimately what that new request will do, we're just going to be able to communicate with the API pretty easily on our local before we're actually writing any application code around that. So this is called the, let's see, images/generations API. That's the endpoint path. And so we have v1 images generation. So we're going to take this whole path, and in our REST client, we're going to add it here. And it's a post request like we've mentioned. So if we just send that off, it's going to say, oh, you didn't provide an API key. You can see in the headers here, this -h means header in for curl. That's how you pass it as a parameter. And so this, we have a couple headers, just two of them. So content type of application JSON. So that means the API is accepting JSON. So as a request body, it will accept a JSON payload. And so we need to provide that as a header. If you're using Insomnia, the second that you toggle this JSON body here, it automatically adds that header for you. In addition to the header, so you'll pass in the API key. So I already have that configured on my Insomnia here. But ultimately what you do is you pass in this bearer, and then you can just paste the raw API key for the sake of not exposing like secret keys on a stream. I've already have this configured in my environment here. So it's just a basic object for configuring Insomnia. But really, if you're just following along, you can do like your API key. It doesn't have to be this like variable in Insomnia. So keep that in mind. But it's good to just not expose these things because somebody could take those keys and basically run with them. They could rack up a huge bill, and you want to make sure that these things remain secret. So, so with that aside, what we can do is, let's just see. So now that I have the API key wired up, incorrect key, you can find your API. Okay, so I probably have an old key. So what I'm going to do is I'm going to generate a new key. I'm going to do this off screen for just a moment. So I'm going to create a new secret key. Click OK. I've copied it to my clipboard. This is my new key, March 26, 2023. And off screen here, I will configure this to use that new key. And so let's see if we send a request now. Okay, cool. So we got past that error, and the new error that we get, still a 400, but now its prompt is a required property, meaning prompt here. And is this something that we could just read in the documentation? Well, sure enough, you definitely can. So in terms of the API spec, we're going to this endpoint that we're working with. And you can see, just as the error insinuates, prompt is a required property. It says the same exact thing here. And so it's a text description of the desired images. So let's pass in a futuristic race car. And let's see what this comes back with. Might take a hot second, but we'll see. Cool, so we get this URL, and as I kind of figured, it's a URL that's already given to us. We don't have to configure any hosting or any of that. But wow, that's kind of cool. So it came up with it took our prompt, which was a futuristic race car, and it essentially generated the image behind the scenes and gave us this URL. So let's see if we can maybe just create a little application around this. So if we have they have kind of a couple examples with their DALL-E preview app, and it has this input and it has this array of just images of different sizes and all that. Maybe we won't make it that cool, but we can make it kind of cool. So I'm thinking we just have a basic text input, and then when we click generate, it can create like a various array of images. So as we saw in the spec here, this n, which is the number of images to generate between 1 and 10, we can just say, hey, give us 5 images, give us 10 images, whatever that is, and that could make a cool little layout like this. So let's see. Let's see what we can do with that. So we know how to hit this API. We know how to make a request. Let's just try giving this n, and let's say n of 4. And we should probably get 4 URLs at this point. And I imagine they'll take a little bit longer, but yep. So if we click through, there's 1, 2, 3. That looks kind of lame, but and 4. Cool. So you get the idea. You give it a prompt, and it will ultimately generate some images for us. So looks like my computer's running low on battery. Bear with me 1 second while I grab my charger. All right, so now that we have a quick idea of what we want to build, I don't know, just something like this seems like cool project to imitate. I think this will be a little Sunday fun day. So let's create an API that essentially wraps the external call to OpenAI. Since we want control of it, it's our application. We don't want to be beholden to any changes that OpenAI sends our way. So if they ever change the spec of their API, if instead their response is something different, instead of this data array, they change it to a key called images, that would it would likely break our front end if we're tightly coupled with OpenAI's spec. So what we want to do is we essentially will have our front end send requests to our backend server. Our backend server will then send requests to OpenAI and any other third parties in our application that we decide to talk to. But this way we know and we control the contract. So if we say the front end sends this data, this request payload to the backend, we can always maintain control of that. So if something changes under the hood, like on the OpenAI side, our API can handle those changes, and our client application, our front end, doesn't break. So maybe the back end breaks, but it's a quicker update to just change it in one spot. We're not tightly coupled to what OpenAI is sending to the application. So let's just get rid of this. let's comment that out for just a moment. So let's create our own endpoint. So from our front end, which we'll mess around with that some more in a moment, but basically let's send it. From our front end, let's send API request to /API/OpenAI. That's our endpoint that we've come up with on the fly. This is arbitrary. This could be like OpenAI images. It doesn't really matter. Just to keep it concise, let's call it just API/OpenAI. So res. So with Express, when you send a request to this endpoint, a post request in this case, to this endpoint, Express will invoke this callback function, and we're defining this function inline. You could define it, outside of this, so we can, and maybe just to illustrate that, just to give you kind of another example of how you could do that. So we could have, let's make this an asynchronous function because it's going to fetch data, and that data is not instantaneous. We saw that it was taking a couple seconds for the request to resolve. So it would take a few seconds, then it returns the list of images. So in that case, it's going to be an asynchronous function, and let's call this handle request. Handle So essentially, like, this is a service method. So you have your controller, which essentially is this endpoint, and it accepts the request from your application, and the callback when a request is sent to this endpoint, a post request sent to this endpoint, it then invokes some other function. So again, we could define this inline, or we can extract it to our own function. But basically, from there, the signature of the function is Express will pass in a request and a response into this function here, and we can use those request and response objects that are passed into us. So maybe we can just check out Express.js again really quick. Getting started. So we're creating a post request. The path is the path of the endpoint. So that's this here, this /API/OpenAI. The callback is the second argument to this. So callback functions can be a middleware function, a series of middleware functions, an array of middleware functions, or a combination of all the above. So you can provide multiple callback functions. So this, imagine if you had a protected endpoint that had some bit of authentication. So you could create an authentication middleware that makes sure that the request itself is valid, and the user requesting it has authorization to view the resource. And so similarly to what we're doing here, they've defined a function here, and so we can just extract that, or we can write it in line, but let's just extract it just to give us a different flavor of what that might look like. And maybe just to see some example middleware functions. So a couple different things going on. Not exactly what we'll be doing, but we'll show that in a moment. So yeah, this is a little more in line, these examples here of what we'll be doing. So we're, like in this case, it's a GET request, so it's slightly different than a POST request. But GET requests are like fetching, viewing data, reading data, whereas a POST request, generally in the HTTP specification, that's where we're mutating some type of data or creating data for that matter. So in this case, you can see they pass in an ID. That's how you indicate a parameter. And they're extracting that parameter. It's named the same thing as it is here. And to the client, it's dynamically sending like a string that says user and then whatever the ID was that was passed in here. So anyway, let's keep moving, but that's a GET request example. Again, we're working with a POST request. So let's mess around with this a little bit more. So what we can do is, so we know that we're going to send a prompt from the UI of our application. So in the request body, we'll have something like this equals, so on this rec object, this request object, there's a body object, and in the body, that's like the arbitrary payload, the JavaScript object that we're sending along with our request. So we're going to just agree upon with our front end and our back end. We're creating this contract, so to speak, that the front end is going to send an object and it's going to contain a key called prompt. And then we'll take that prompt and use it in our service method here. And so in this case, when we're doing this, we know that this is going to exist. We can just say, like, let's destructure the prompt from this body object. And so now that we have a prompt, we can do something with it. So with Express, when we want to return something back to the client, we have this like res.json. So I wonder if we have a little bit of documentation on that. Sends a JSON response. This method sends a response with the correct content type. That is the parameter converted to a JSON string using JSON stringify. So you can see a couple different examples. We can chain the status. We can send just a JSON object back to the client. And in our case, I think what we want to do here is we're going to just send back, just to get this thing working, we'll send back an object that has a key of prompt, and then the prompt itself is what we've destructured from the body, from the request body. So really not going to be doing much, but let's just make sure that we've wired this thing up. And here we're just passing in the function. When the function gets invoked, we know because of how Express works, how Express passes in these callbacks. So let's go back for just one moment. Application, app, get, post. So these middleware functions, you can see there's technically 3 parameters. So there's this next parameter, and we don't need that, so we won't concern ourselves with that right now. But essentially, from what I remember, it's just if you're defining a middleware that has to go to the next step because maybe you have an authentication middleware, then the authentication middleware calls this next function. In order to get to this next function, this service method, so to speak, in the authentication middleware, so auth middleware, might as well just try it out. Rec res next, and okay, so all of the Express middlewares get called with these 3 parameters. In our case, we don't necessarily need to pass in this next parameter into this like service method because we're not going to be making use of it, though we could. But you can see here in this auth middleware, so if we go back for just a second and we read the spec here, so app.post, let's see for just a moment. So yeah, as it said, a series of middleware functions separated by commas or an array of middleware functions. So what we could do is we could just either separate them by commas, see these handlers here. Okay, so let's call this OpenAI handler. OpenAI handler auth middleware handler. And so it's just this array of handlers, and presumably Express under the hood, as a request comes in to this endpoint, it invokes this handler with this signature. If the next is called, it then goes to the next handler itself. So all right. So, excuse me, I had to take a quick break. So, all right, next thing up, let's just try to send a request with Insomnia. And let me find my Insomnia. Keep this off screen. So we have created our own endpoint on our server. Our server automatically reloads, so we don't have to restart our server when we make changes to the backend, which is kind of nice. So we're using NodeMon for that. And so this request was to actually like OpenAI.com's API. So our API that we've created is running on localhost 3000, and that's displayed here in the server listening. It logs out the actual like URL, the host name that we're building our server on. So so that's going to be localhost 3000, quite common. The endpoint that we've defined, again, could be arbitrary, but we've just called it /API/OpenAI. And so for Insomnia, let's go ahead and pass that request in. If we send a GET request, right, you can toggle the various HTTP verbs, so GET, POST, PUT, PATCH, and so forth. It will say it cannot get this endpoint. But when we send a POST request, you can see now we have a 200 OK. So we actually have a response that comes back from this. So you can see here how we have this authenticated ... So this means that the auth middleware was invoked. And so in our case, the interesting thing though is that the response was just an empty object. So what if we did this? What if we said prompt is set to prompt? Now I would imagine, because we're not destructuring this, or I forget the exact term for this, but we're not like saying, hey, prompt is set to prompt, because prompt right now is undefined. We're not passing in anything into this JSON request body. But if we set this, now we should get in the Insomnia prompt. And sorry, I wasn't streaming that. But basically, this here, we had it as this. This value, we haven't passed in anything here into the request body. So therefore, prompt is undefined. So when we basically like use this shorthand syntax for because the key is named prompt and then the variable name is prompt, our JSON response in Insomnia was just an empty object. But I bet if we do it like this, we'll now have a JSON object with a key of prompt, and then it'll be undefined, I would imagine. And so let's go ahead and just fire off another request here. So, okay, interesting. So we don't actually have that. I guess it's not super important, but I am curious to see why that's not working. So it's probably because this is failing to destructure this value. And if we wrap this in a try catch, I wonder if we'll see an error. Try catch error res.json error, and then we'll return that to the client. So if we fail, let's see if we get, okay, we're still not getting anything. So this is cool. Let's keep playing around with it. So in this case, let's try to say, instead of destructuring it there, we can just call it prompt equals rect.body.prompt. And again, we know we're not passing in the actual prompt yet into our Insomnia request, but we'll do that momentarily. And so let's go ahead and just try it. Prompt, like we kind of saw earlier, we could do, a futuristic race car. It doesn't really matter. Give it any kind of prompt that you could imagine, and it's going to try to give you an image to generate from. So kind of cool. So, all right, interesting. We do get the prompt back, which is cool. So we can remove this try catch. We don't really need it for right this second. But you can see here, when we do pass in a prompt, it will just very like more of a sanity check that our API is wired up. We're passing that back. So let's go ahead and destructure the prompt key from our request body. And then if we don't have a prompt whatsoever, then let's just go ahead and throw an error. So if not prompt res.status, let's make this a 400 because it's a bad request. And then let's just say something along the lines of error, a prompt is required. And let's try it again. Let's call this something else. And so this key needs to be prompt, otherwise this request is going to fail. So let's make sure that, cool. So we get a 400, and sorry, I'm new to Twitch streaming, so trying to show all this stuff. So we have a key that's not called prompt, and we're passing that in the request body. If we don't have that key prompt, then it returns an error. So cool, let's swap this back to prompt, and let's just fire off that request again. And oh, app has crashed. What happened? Error, stack trace, cannot set headers. Oh, right, because we have to return here. If we don't return here, then let me hide this for a second. If we don't return this value here, the execution will still continue. So when we're writing the response body here, it then continues execution down to here, but we need to return in this case and halt the execution after we've written our response. So we can, express is basically saying you cannot set the headers after they are sent to the client. So if we're not returning here, it's trying to set the headers and write to the writable stream again after this right here. So we have to return if we're doing some error handling and writing to the response. And then just, it's kind of implied that this is returning here, but just to be explicit, let's throw a return there again. And so now our server boots up again using NodeMon. And if we fire off the request with Insomnia, cool, we get this basic prompt. All right, so now we know that if we're sending the request to OpenAI itself, we're basically giving it this prompt, but we want to control it on our backend server. Our backend server then makes this request to OpenAI. So we're going to wire that up in just a second. But basically, this is sending the request to OpenAI, and it's giving us an image, like we saw a little bit earlier, of a futuristic race car in this case, because that's the prompt we gave it. And so to keep moving, so what we want to do next is we're going to want to send this fetch request. So it's going to be an asynchronous operation, and we're going to send it to, if we're looking at the API spec, it's that same API we were messing around with just now here, and we can actually just copy this. This is OpenAI's API, a post request to that URL. So we have this. Let's use the native JavaScript fetch API, and we know that the default method for fetch is get, but in our case, it has to be a post based off this here. And we have a couple headers that we want to send along for the ride. So in our case, because we're sending a JSON body, we'll be sending application JSON, so it knows what content type we're sending. And because this is an authenticated, there's basically it's a secure endpoint. We have to pass in this other header. So you can see the one we just added, but we also have to pass in an authorization header. Again, this is pretty standard stuff for secure endpoints, but we need to provide it the bearer token. And the bearer token is going to contain the API key we generated a little bit earlier on. So I'll do that in just a moment. And so this can be, because there's no hyphens in it, doesn't need to be wrapped in quotes like the content type does. But in this case, what we're going to do is bearer. And then, so what we need to do is we don't want to just paste our API key for the whole world to know. We also don't want to save this in our repository. So what we can do, I've already set up this boilerplate, and this boilerplate pulls in, it reads from a file called .env. This is pretty standard configuration. So the env.example, what we can do in this boilerplate project is we just copy, we can paste, paste, and then let's just rename it to .env. And you can see the .env file, it already has this port configured for it. So we're just going to create an OpenAI API key variable. I'm going to take this off screen for just a moment, but what I'm going to do is essentially paste on the right side of the equals here. I'm going to paste the API key that I'm getting from this here. So this is the key I just generated earlier. I'm going to take that key and essentially paste it into the env file. And so now if I reboot my server, you just have to reboot the server if you make changes to the env file, only because it needs to load that on startup. So a hot reload using NodeMon will not work. And so you can see we have some errors here, and that's just because we didn't finish what we were doing in terms of pulling in the environment variable. So we called that OpenAI API key. And so now through our configuration file, this .env, we're pulling in the API key that we've generated. And so the next step, what we want to do here is we need to pass in a request body. And looking back at the API spec under documentation and, API reference chat, and this create chat completion, this is the one we're working with. Images. Chat was what we did yesterday. Create image. The request body requires one field, and that's called prompt. All these other parameters are optional. So we'll probably mess with some of these, but we just need to make sure that we pass in a prompt. And if we don't, let's just see what happens. So body JSON stringify, and let's just pass it in this random key value of hello world. And so if we need to set this to a variable because we need to do something with it after the fact. So let's set it to something called response. Pretty typical if you're working with the fetch API, which is really nice. It's a native JavaScript API. I definitely encourage reading up on it if you're not familiar with it. And sorry, this is actually, just to call out, this is the Node Fetch API, so it mimics the browser Fetch API. So just real quick, it's a very popular library, and it's a way for us to send external API requests that mimic the same Fetch API that you would find in the browser. So it's almost like you kind of have consistency between the front end and the back end. I will say the newer Node.js versions, I think Node version 18 and onward, has essentially this package built right into it. But you can see 45 million weekly downloads. It's quite popular. And it's basically just how we can send API requests similar to how we would send them from the front end. So there's that. So we have this, we'll take the value of the response that we get from this asynchronous fetch request. We're going to set that to this variable called response, and then we're going to take the data from that. So let's create a variable called data, and this will also be asynchronous. We're going to say response.json. So basically, like, make the fetch request it's going to return a response, and that's why we're setting it to this variable called response, just to be more, a little bit more clear. And then when we call this .json, it destructures the response as a JSON object, and then we can do something with that. So that should be the data that we're getting back from the API. And just to refresh, this is the actual response payload. So when let's console log this, but we should ultimately get the same stuff here. So it should be like a created with a data key, which is an array, and then it has an array of objects that contain URLs. So pretty straightforward stuff, but let's just sanity check that we do see exactly what we imagine. And so let's call this. And on our terminal, so I'm logging this response. So when we fire off this request, and let's see, to Insomnia. So this Insomnia request is to our own backend that we've been creating. And we're just sending it a prompt, and it's still going to return the prompt because we haven't set that up yet to return something different. But the console log is logging the data from the response itself. So this is actually coming from OpenAI's API. And you can see it actually kind of complains about, hey, like, these properties that you just passed in, they're not allowed. So just to refresh, what is it asking for? It's asking for a prompt in the request body. So let's go ahead and give it that. And we already have the user's prompt here, because if we've made it past this condition, we know that the user has provided us with a prompt on the front end. So in this case, what we do in the JSON body, what we can pass in is the actual prompt from the user. So similar to what we're doing down here, we just have this JSON prompt. But so let's pass this in as the request body, the user's prompt. And is there anything else that we care to pass in? The number of images to generate. These are all optional, but let's go ahead and say, give us 3 images. Anything else? Size, response format. We can come back to these if we care to later on. So we should get back in our console log here for our terminal. We should get 3 different images in this array now. So sending off this request with Insomnia. So it says we're authenticated. We're just using this like fake middleware just to illustrate how Express middlewares work. And so that's this like mock authentication stuff that we're seeing get logged out here when it says authenticated. And then just like that, we have the actual data coming back from OpenAI's API. So the request comes in from the client, sends it to our backend server that we've created. Our backend server, then, let me hide this. Our backend server then gets to this point where it sends the request to OpenAI, and then we're just logging some data. So logging's useful as we're developing, but let's go ahead and make this actually return something as part of the API request. So instead of logging the data, all we really want to do is get the data off of this. So this like inner data that we see here on the terminal, that's an array of URLs. So for our application, if we're to go back to like this basic application that we're just trying to mimic, we have this user input. And we could imagine for our example now that we have this user input already built. And then so our API is accepting the input. That's what this prompt is that we're passing in, that comes in as part of the request body here, kind of makes its way down. And so this is the user prompt, right? And then we kind of want to just display some nice images on our UI. So all we really care about probably, we don't care about this created, which looks like a Unix timestamp from Epoch, which we don't really care about that at the moment. But let's take this data value. It's an array of objects that contain URLs to the generated images. So And again, like we changed this parameter to be n equals 3, there's 3 images that the API returned. So in this case, the response itself, let's to not like confuse things, let's call this, I don't know, payload. And so that's the payload that we're getting back from OpenAI. And so the actual data that we care about lives on payload.data. And so it's a little confusing the way I had it named data.data, but now let's just send one more request. I'll click the button on Insomnia off screen. The request comes back. We're console logging this as payload now. And so we've called it payload.data is this array. So the array that we want to return that we've already wired up here, now in Insomnia, because we just sent that request, you can see in Insomnia, the actual response payload is the prompt and the URL. Well, that's weird that we're naming it prompt. So let's just name it data because we were just giving an example, returning a prompt earlier. But we know that this is going to be an array, payload.data. That's what's coming back from OpenAI. And so our API contract is returning a JSON object with the shape of just data. Like it has just this data key, right? So let's fire off one more request. And we changed this key here. I keep doing that, but having it hidden by accident, I didn't mean to do that. So now our response in Insomnia is an object that has a data key, which has the array of images. So pretty cool. I think the only other thing that we would want to do is just add a tiny bit of error handling. So let me hide this. So if we get this response back, so on the fetch API, there is a property that we can check for. So if response.ok, and we want to check if it's not okay, because this is a Boolean value, and it will basically just tell us, and you can see here, response.ok is a Boolean. If the response is not okay, similar to what we did here, let's just return an error. So let's stop execution early, and let's set the status. We could, in a production application, if we were to do this like in the quote unquote real world, and we would want to handle all the error cases, so the various responses that come back from this API that we're working with. I imagine we could find those somewhere here if we were to dive in. Let's just return a 500. I hate 500s in general. They're not descriptive at all. But in this case, we're using it as a catch-all that, hey, the response failed for some reason or another. And let's figure out why that response failed. So I think we saw earlier that there's actually like an error that was given to us when we didn't have the API key, or when we passed in like an invalid request payload. So let's see if we can just snag that and send this back to our client. So here we're going to send JSON back, and we're going to have an error, and it's going to be payload. I think it's payload.error, but let's console.log. Okay, so I'm pretty sure that's what it is, but let's just confirm that before anything else. So we're logging. In order to get this to throw an error, all we have to do is just like not pass in an API key, like invalid key. Doesn't matter what this is. This should fail because we're no longer authenticated, or authorized, I should say, in order to send requests to this resource here. So let's go ahead and off screen sending the request. And so actually with Insomnia, you can see that now we have that 500, and the error in the logs here, which I guess even I could have kept this on the screen, we have the error, and that's sent to, okay, incorrect API key provided. So we could just send this back to the client if we wanted to. We could handle all these various cases if there's no API key, if the request payload's bad, all that stuff. If there's a server failure on OpenAI's end, we could pass in all of those different possibilities of errors. So I think in our case, so we have the dot error, which is this, and we have this message. Sometimes when you're building an application that uses third-party APIs, you don't want to pass back to the client, to like your end user, exactly what the third-party error was. Like maybe you want to keep things kind of vague so that your end user doesn't like know that you're using like OpenAI under the hood to generate images or whatever. Most people would probably know that nowadays, but for the sake of our example, let's just send it the message that's given to us from OpenAI. So let's add the API key back, and this was on error.message. Cool. And I guess let's just try it one more time. If we send the request back, cool. Invalid authorization header, that's because we removed the key altogether. If we add some semblance of an API key and then try the same request, there you go. We got that same error that we saw earlier. So cool. So let's add that back. Send the API request. We should no longer get an error at this point, hopefully. Cool. And now we see the successful response with the data coming back. And so we have error handling, very straightforward error handling. Again, we could handle all the various cases if we wanted, but let's keep going. So we can work on some UI of this. So the UI, again, off of this boilerplate, and for anyone just following along, there's this. I'll hop back to it really quick. This is the boilerplate project template that I've created. It's a very basic full stack application. So this is what we're building off of today. And to open the we've installed the NPM dependencies. This is what the front end actually looks like. It's already kind of wired up for like our case today, because all we really wanted was to kind of mimic this thing here, this like, you know, DALL-E example app that they have where you enter a prompt and futuristic race car is the prompt we've been going with today. And so we can see we enter the prompt. It's got a cool kind of loading indicator. So maybe we can add one of those as we go. But cool. So we get some ideas of like what it generated. It shows us the 4 images in this case. So I think like for our purposes, all we have to do is just tweak this kind of a little bit. So we have some basic UI, and we're using Tailwind CSS, which is a great library for styling CSS. This is their component library, which is paid, but if you use just their CSS framework, it gives you all these kind of descriptive class names of like what exactly you're adding. Instead of having to write out all the CSS, they kind of give you a lot of nice CSS out of the box, and it's very extensible if you want to add your own CSS, custom classes and stuff. But I use this for almost all my projects, and I think for today we're going to continue using this and give it some couple tweaks on our HTML here. So let's just edit some stuff as we go. We already have the label. This is for screen readers only, so we're not seeing this text of your name here. If we were to inspect the HTML like so, we would see that element somewhere here. Where is it? In this section, div, yeah, your name, but see it's hidden from us. So it's for screen readers only. It's good for accessibility. Enter your prompt. So we'll add that as the screen reader text, and then the placeholder that we have for this input says, what's your name? Let's go ahead and just add this as enter a prompt. Refresh, enter a prompt. Submit. I think all of that is okay. So when we click submit, it should probably do nothing. It should actually fail at this point because we've already wired up our own API and removed the endpoint that this was using. Yep, so it says 404 not found. That was this commented out endpoint that we had right here. So if we did add that back, then our terminal reboots, we refresh the page, we say, hey, cool. So it's wired back up, but we don't want to use this. We want this to communicate to the endpoint that we created here. So in order for us to do that, so this main.js file is where our backend logic lives. We're not going to be messing with that too much at this point from this point going forward. So on the client side, we have our JavaScript, our client-side JavaScript, and that's located in client app index.js. That little example I just gave us of like entering the prompt and then it had this little alert box up here, that's what was making this happen. We can take this and ultimately rework it for our purposes. So let's say handle submit prompt is the new function name. And this is one of the keys right here, this piece. So what this does is this is going to get the user input with ID, and I'll zoom in a little bit, with ID of name form. Let's give that a different ID while we're at it. Split this right. Let's kind of zoom in a little bit. Okay, so we have an input and we've given it an ID of name, but then there's an ID of name form. So let's call this prompt form. And on the side over here, what we're doing is we're basically latching on to that. So we have this form. We're going to grab the element by its ID, in this case, prompt form, like we've just set it to. And then we're attaching an event listener to that form. And so the event listener, it's listening for submit type events. So forms out of the box, HTML forms have this submit event. And when a submit event is emitted, AKA when somebody clicks a button that's attached to this form, you can see we have this button and it's of type submit. So when somebody clicks that button, the DOM, the browser essentially emits this event and this submit event. And when that happens, there's a callback function, this second parameter here. It invokes this callback function called handle submit prompt, which is what we just renamed this function to. So when we invoke this callback, that's how we get to the next. We basically run all of this logic that's in here. So you can see there's a parameter. It's very non-descriptive. It's E. This is kind of convention across event types on the DOM. You can name this event. You can name this whatever you want. But basically, when we call e.prevent default, what this does is, so let's go ahead and let's just comment all this logic out. Let's console.log clicked. So I'm going to hide the terminal since the terminal is outputting stuff from our backend server. We're not going to need that for right now, but all of our console logging here is going to be on the client side now, since this file is all of our front-end JavaScript logic. So basically, when we, let's see here. let's just enter a prompt here, click submit. In our console, you can see that clicked was logged, which is what we just added here. So you enter it again, clicked, click again, clicked, and so forth. A little bit easier to read here. Cool. If we, but what happens though is when we click this, the default behavior of a form upon submit events, like we've talked about, take a look at this little like favicon. You'll see that I'll move this over here all the way to the left. When we click submit, the actual like browser tab, it refreshes, and we don't want that. We don't want this to refresh because then we kind of lose some of the state that we have in the application. Normally, so what we want to do is prevent that. So that's what this, so an event is passed into this callback, and we want to prevent the default behavior. And the default behavior is what's causing the tab to refresh. So now when if we click submit here, we should no longer see all these additional logs that only appear when the page is refreshed, like in the console to the right here. But when we click submit, now we just see clicked. So we're preventing that default behavior. And that allows us to do some other cool things. So instead of it refreshing the input on the form, which is where the user types their prompt and all that good stuff, now we're preventing that from happening. So that way we can take those values from the inputs, and let's get rid of this so we can write it from scratch just to see how it's actually done. So what we want to do, let's close up the sidebar so we have some more room. So on the front end, we have this label, and again, that's for screen readers. It pertains to this input here, which has an ID of name. Let's give that a different ID. Let's call it prompt. And the label is for that input of prompt, and the name of this input. So this is usually useful for form submissions and stuff like that. If you use them in their traditional sense, we don't actually, let's see, we don't actually need that. At least I don't think we do at the moment. So let's come back to that if we do. But basically, if we refresh, don't really get a whole lot of changes that are visible to us on the screen. But let's rename this OpenAI Image API. Refresh. Cool. So now we have the new title. Enter a prompt. And so when a user enters a prompt here and they click submit, we want to take the text that they've entered into that input and send that in a request to the backend that we've created. So how do we do that? Well, what we can do is take the input by its ID, and there's this is a great way of working with the DOM, just using like kind of vanilla JavaScript. But so we do document, so we're taking like the DOM, and the DOM is the document object model. So it's just a way to model what the browser screen looks like, and it's made up of all these HTML elements and all that good stuff. Just a quick aside, you can view page source, and effectively like each of these HTML elements under the hood have their own properties and ways of interacting with them, and we'll see that in just a moment. So we want to do document.getElementById, and the ID we want is this prompt ID. And so now this is taken in JavaScript. It's essentially latched on to this user input, and basically now we can manipulate and get and retrieve values from that. So let's just see, I guess what happens if we just console log this HTML element. We're probably going to get some like weird output, but it'll hopefully illustrate what we're seeing here. So this all happens when we click submit. And so you can see it's actually the input itself here. that's defined in the HTML. However, under the hood, the actual, and let's look up MDN. So I think it's like mdn.org. Okay. Okay, so it's these, the Mozilla docs, and so document.get element by ID. So let's look at the API for the get element by ID method call. And so it returns a value, which is an element, an HTML element. In our case, it's the input, which we saw here. This is, we actually just logged that element to the console. And what we can do then is, like, you can see how it has this element, it's set to a variable, and then it's just changing, in this example, it's changing the style, the color of that element. So clicking the button does that. So it's pretty cool. So we have different methods on these HTML elements that change the behavior, that allow us to access various properties on these on these HTML elements. And so let's see if our IDE, it does look like it gives us all of these properties. And so let's think about what we're trying to do really quick. So a user enters some text, they click submit. We want to make sure we get that text that they've entered, that dynamic text provided to us by the user. How do we get that? So there's this property called value, and let's see if that gives us the text that we want. So if I enter Twitch, it gives us the text entered by the user. So that's exactly what we want. So now that we have the user's text, the user's input, we can set this to a variable. And because we've referred to this as prompt in a lot of other places, we don't have to call it prompt, but I think just for the sake of consistency, let's just be clear and continue to call it prompt. And so what we want to do is, now that we have the user's prompt, we need to then send it to our backend server. So if we recall, the actual server, our server is listening on localhost 3000, and the API the endpoint that we're hitting is this API/OpenAI endpoint. So what we want to do is, on the client side JavaScript here, we're going to send a request very similar to what we did to send this external request. And then we take the response, we set it as a variable of response, then we manipulate the response and send it to the front end. Very similarly, we're going to send a request using fetch. So because our function is marked as asynchronous, we can now use the await syntax in here. And you can see if I remove async, await is like, whoa, wait a minute. Await can only be used in an async function. So we have to mark our functions as asynchronous in order to use await. So in this case, because the application is already running on localhost, we don't have to type out HTTP localhost 3000, though we could, but instead we could just do our endpoint, the path, which is API/OpenAI. If we recall, this actual endpoint accepts only post requests at the moment. So the method that we're sending is a post method. Headers, very basic headers. If we want to send JSON as part of our request body, we need to define the content type as application JSON. And then in the request body, hopping back to this, the request body that we've kind of agreed upon, that the front end is going to send and the back end is going to receive, we've agreed upon this contract, so to speak, of sending an object that contains a key named prompt. And so the request body, so when we pass in this request body here, that's actually what this rec.body is here. So request.body. So we're passing the request body in here, and we need to have a key in this object called prompt. And so we could do prompt : prompt, or because JavaScript has this nice shorthand syntax, if the key is the same as the value, you can just pass it in once. Okay, so now we're sending a request to our own backend server here with the user's prompt. And we have to make sure that we store the response in a variable. So let's store it in a variable called response. It's very similar to what we're doing here because we're storing the response from OpenAI's API response in this variable, and then we're doing some stuff with it. So a lot of this will look similar as you're sending API requests throughout your applications. But in this case, what we want to do is let's, similar to what we did for the backend, let's call a variable called payload. Let's take the response. Let's await the response.json as a, I believe this just returns a promise as it gathers the date. Yeah, so you can see the signature is a response. A promise that returns any type. So because it's a promise, we must await it. And then we can take the payload and we can console.log the payload. And let's just see what that looks like. Let's see what's coming back. So now we've found a way to handle the prompt from the user and pass it to the backend server we've created. So let's give it a prompt, futuristic race car. And it logs out the prompt, and momentarily, let's see if it comes back with anything. And it's possible, in our console. Const response, OpenAI, prompt, payload. Okay, so we might have, let's see what this says. Let's try this again. So let's see what the API request looks like. So our request is pending. Pending, it comes back with a 200. The response from the API is as expected. All these image URLs generated by OpenAI. And yeah, so in the console, so it took a second, and it gives us the URLs based off. And so these should look like, you know, a futuristic race car. So let's just double check what that looks like. Very cool. Okay, so now that we are able to send those requests, we have to do something with this response. And so we know that it comes back in this shape of, you know, an object that has a data key. The data key is an array of these inner objects that contain URL keys. And we want to get to these here. And so in order to do that, let's see how we can handle this. So somewhere on the front end, we want to add a section. And we want to just display images, right? So keyboard's about to die. All right, so section, let's create an HTML section. And let's think about this for a second. So we just want a, I don't know, we just want a basic layout. Like if we're looking back at the kind of mock-up here, can we just display a few images like this? And so I think so. So let's create this div and give it a flex class. Just as for good measure, let's give it a border. And let's give it a height of, I don't know, a random height. So these are all Tailwind CSS classes. I use Tailwind a lot, so I kind of know a lot of them off the top of my head. And let's give it a width of full, right? Oh, got to give it a width, another arbitrary width. Okay. Cool. So what we're trying to do is, and let's just take these images and from our response, let's take the URLs that we have and let's just like hard code them into our application. Let's build like a, let's hard code it, and then so we can programmatically add these. So we're going to give it an image with this source. Does it like this or no? I don't know. Image 1. Okay, so it just wants the alt tag. I think that's part of the new spec with HTML, which is totally fine. That's good for having alt tags is important for accessibility. Okay, so the next source. So yeah, you see how the syntax is white. That's why I was kind of wondering what was going on. But then the second we add a alt tag, it stops complaining. And let's take this third. Okay, so we have this other one. Okay, cool. So we're seeing the layout shift a little bit. It's not like ideal, but let's try to style these a little bit. So let's just work with one at a time. And let's give these some class names. Let's round out the border radius. Let's give these a border. Border 2, border. So border width is 2. Okay, if we give these, let's give this outer container some padding so that way there's like some breathing room for the images to be displayed. And cool, so it looks like we have like an image displayed, and if we can add a little bit, so it's kind of, let's see, I thought I saw some like nice little drop shadow. So we give it this like shadow class. And so that looks kind of cool. It's got a drop shadow. Let's make the border like a little bit lighter. So that looks kind of cool. Get rid of this red border since we're just kind of debugging a little bit. Cool. So we have these images here, or this one image at least. Let's add the same class to these others. Cool, and then so they all kind of have this nice little effect applied to it, but it's still, I don't know, it's still like a little still a little weird. So width fit. Okay, that's definitely way off. Okay, so if I add this like kind of debugging CSS border around just to see what we're working with. So what I just did was the height of the container that holds all the images is set to like this 96, it's like a Tailwind class, 96 rems or whatever that is. Let's take a quick look at that so it's not like totally unclear. But let's go width. So they have all of these like kind of classes that we can piggyback off of. So when we say something is w-96, width 96, that equates to CSS setting the width of the container to 24 rems. So these 24 units, right? And width screen, sorry, height 96, and then width of screen. So it was height, not width of 96. It's the same thing. Height 96, 24 rems. So same thing as the width that I just showed you. And then for width, we go back to this. We have a width of screen, which is 100% of the view width or the viewport width. So whatever, however wide the screen currently is, that's what it's going to be for that container when we set it to width screen. So then we've given it some padding, which is kind of nice. So it gives like some breathing room around the edges. We could add more, we could add less, whatever. But that's kind of what's going on here. So, well, if we only have 3 images, it's kind of weird that they're like all to the left. We kind of want them centered. And so if there's 4 images, it will center. If there's 2 images, it's centered, or even just 1. So with Tailwind, since this is a flex box, we should just be able to justify center. And that gives us the images in the center, which is kind of cool. So the next thing we could do just as like a nice touch is item center. So this will vertically center the items in the box. Oh, okay. So that kind of screwed things up. All right, let's leave it without it for now. We don't need to spend too much time on that. The other thing though is like these images kind of also don't have any breathing room from like left to right here horizontally. So what we can do, because this is a flex box, a flex container, we can give the spacing on the x-axis 4 units, 4 rem or whatever that equates to in Tailwind. And so now there's like a little bit of breathing room. We could make it, you know, 6 units, whatever feels right to us. I think that looks okay. And then I'd probably just make padding something similar for consistency. It's not necessary, but cool. So we have this, we have these prompts. We have the ability to accept a prompt, and then this will return, or at least we have the image layout kind of figured out. So that's the container, right? So we've added this class to these images, but we've hard-coded the images. So how do we dynamically add to the images here? So, or sorry, to the layout when we get the new images back. So let's think about that. So what we want to do when we submit the prompt, we want to keep our functions lightweight. We don't want it to do way too many things. When we keep them like the kind of like the rule of thumb is to have your function do one thing. And so ultimately this is handling the user submitting the prompt. And then if we really wanted to adhere to that principle of just keeping your functions to do one thing, we could make a separate function that sends out the API request. We can probably refactor that later. But what I do want to do is make a function that solely adds the images to the to the DOM here. So what that will look like is we're going to have a function and create add image element to DOM. And it's going to take a parameter called image URL. Since this will be dynamic, we're going to pass this into this function call. And all it needs is the image URL, and then this function will handle the rest. So what we're going to do is create an image element, and const image element equals document.create element. And we give it the HTML tag, which is img, so image, and we're going to set the source of the image element equal to the image URL. And we can set the alt attribute to be, I mean, we could set this to be like the same thing over and over and over. That's probably not the best practice for accessibility. So just because this is a pretty lightweight tutorial, we'll just, well, I guess we could do like generated image, and then in theory, we could have a unique alt tag, which wouldn't be useful for the, okay, let's pass in an image number to this function call, and that way our alt tag has the image number. So it would be like image number 1, 2, 3, 4, 5, and so forth. Okay, so the next thing we want to do is like, how do we take this element? So now that we know that we're passing in the image URL and the number, how do we actually add this here like so? And so what we want to do, well, I guess prior to that, what we want to do is add these classes. So we hard-coded these image elements, but let's dynamically add these things. So image element dot class list is how we can add, and dot add is, and so we can see the actual, what this method dot add requires, and it's an array of strings. So we can give it the various classes that we want to add to this image tag. So we rounded border radius, the border itself of width 1 pixel, I believe, is what just border is as a class name. Border gray 200 gives it kind of a nice light gray. And then a shadow, which is the drop shadow effect of large. And so now we've added the styling to that element. And so the next thing we want to do is we want to basically, similar to how we see them added to these elements here, or added to this outer div here, we need to be able to latch on to this thing and add the images dynamically to this. So one way of doing this is similar to what we did here. Get element by ID. And so I guess for starters, this image does, or this div element doesn't even have an ID. So let's start there. So let's call it like image container. And let's say document.get element by ID image container. And then what we're doing, or what we should be doing, is appending these image elements as children. So it's basically they're nested inside of the div element. And so to do so, we have to call append child, and we just append the image element. So this will take an image URL, this function, an image URL, and an image number, and it does what the function name implies. It adds the image element to the DOM. So it only adds one given image element, and it requires the URL and the number of the image. And then it takes it and it appends it to this container. Cool. So where do we call this function, and how do we call this function? So what we can do is, essentially, we know that in this handle submit prompt, we know that the response contains, or maybe I didn't finish this out. So let's go ahead and finish this. So we have the response. Let's get the actual payload. So let's create a variable called payload. Remember, this is asynchronous. So this .json method on a fetch response is, it returns a promise, so we must await the promise. And the payload, we're logging it. Let's just refresh our memory. A future, let's Okay, so I removed the images here that we had hard-coded, and we're going to log the payload just to refresh our memories as to what the API returns when we provide it a prompt. So we're waiting, and we have received the response. And so we have this array called data, or it's an object that returns. It's a little easier to see on the network tab. So yeah, this looks familiar. It's an object that has a key called data. And then in this data key, it contains an array of objects that contain a URL. So we have to take we have to basically latch onto this data key, iterate through one by one every object in this array, and then extract the URL property, URL key on these objects, and then pass that into this function, right, that we just created. So how can we do that? Okay, so we have so we know that the array, so const images array, let's name that something descriptive, is going to be equal to payload.data. So now that we know this is an array, this is this array here, we can iterate through the images array, and we can call the .map, which is an array method. And the array method is called with the element. So in this case, I'll copy this over here so it's a little easier for us to reason about. But we have, let's just make a comment. Okay, so let's paste this in here. So we have this array, and then it has these objects, right, inside of it. So as we iterate through this array, each object through every iteration gets passed in, and that's available to us here. And we can name this item, we can name it image. Let's name it image. And then we have another parameter that's automatically passed into this callback function, and that's the index, right? So if you recall down here, we have the image URL and the image number. The index that's passed to this is, so for the first iteration, index 0, then it's index 1, then it's index 2. There was, index 3, 4, 5, 6, and so on. That's what the index would be. So now that we have the current instance or the current iteration within the array, we know that now it's an object. So the image .url, because we're accessing the property on the object, the image itself is the image object, and we have the URL. And so actually what we can just do is call this add image element to DOM function with the image URL. So it would be image.url. And then if we need the image number, which we do for the alt tag that we're creating, we just pass in the image, the index that's given to us through the array.map function. And so if we've done everything right here, we should actually now see images dynamically appear on the UI. And so let's see what that looks like. So let's clear some of this out. Let's give it the same prompt we've been giving it, but then we'll try some different ones. So a futuristic race car. We're loading. Request is pending. You can see that by the status over here. And voila, we have the images appear on the DOM. So one thing that we didn't do, though, is we didn't clear out the prompt. And we might want to, just for like a better user experience, probably just clear this prompt out just so the user can just type something in, I suppose, and they can keep just adding prompts, I should say. So How we can do that is we already have the ID for this input because we're taking the user's prompt that they've entered. So after we add the image elements, we can just take the, we can do something similar to this. So let's get the prompt input, which is getting the element by ID, and the ID here, prompt. And let's set the value equal to an empty string. So that way, as we type prompts, we can, it will clear it out for us automatically. So it's a nicer user experience. Very cool. And so you can see it's actually adding to the, oh, but it didn't clear out our prompt. Okay. So let's see. Okay, so I just needed to refresh, and then the new code that we added was updated, and then it would clear the prompt for us once it comes back with the data. Cool. So let's see a futuristic skyscraper. Clears the prompt. Oh, this is cool. And it gives us a few images of our new prompt. Can we clean this up a little bit? Can we make it so that the images kind of display with, I guess, their own prompts? We probably could do something like that. Let's see. Okay, so let's see here. So what we're doing is we are essentially adding, we're just appending like the new images to the DOM as they come in. We should have some behavior that we wrap the images. So it's just like a little bit nicer. So we're not like constantly scrolling to the left or the right. I'd rather that just kind of scroll downward. And so let's see how we could do something like that. Auto on. I'm just reading a message in the chat. Very cool. Yeah, if whoever put that in the chat, feel free to ping me afterwards if you'd like. Maybe we could chat about that. Twitter handle is @CodesnippetHQ. Feel free to reach out to me afterwards. So what we want to do is we want to have a nice kind of grid layout. So instead of scrolling left to right, maybe we keep 3 images horizontally, and then the next set of 3 images will keep piling downward. And so let's see, how can we do that? It's probably just a flex property, flex direction, flex row reverse, flex column. Flex wrap sounds something like we'd want. So flex no wrap to prevent flex items from wrapping, causing inflexible items to overflow the container if necessary. Okay, so let's call it flex wrap. Let's add that class here. And the direction it flexes is in a row. It's probably the default direction, but we added it anyway. Futuristic car. Let's see what this looks like. Okay, so that's not exactly what we want, but let's take another look. Let's see if we can hard code these for right now so we don't have to keep. So let's do this. So we're just going to inspect the page here. We're going to copy the element, and then we're going to paste it in. So this will essentially give us the same stuff that we have on the DOM right now. And if I refresh, those same items are here. So that this way we don't have to like send a request, restyle, send a request, restyle, all that stuff. We'll just be able to edit these things inline. So we have the 3 different image tags, and we could probably add a class on the images. So let me just like auto select. So height 96, width 96. So this way the images are constrained to their own height, and that's already helped us quite a bit. So let's add that to where we dynamically generate these. So let's add it here, height 96, width 96, just so we don't forget. And then we have, so if we added like another 3 images, let's see what that looks like. So that's kind of cool. So it's basically doing what I described, but it's a little like off here. So when we wrap, why is that? So to start, let's add some dynamic spacing on the y-axis. So that gives us like a little more breathing room up and down. So like this image and this image below, they'll have some more space there. So that looks a little better. But we do have some weird behavior in terms of the actual container. So what we should do is this image container that we're building out that holds the images themselves, we because we have this like code snippet logo here, we need to tell this container that it should have a minimum height. So let's do a minimum height of, I don't know, 96. And then let's add some debugging. So border red 500. Let's make this border like pretty large so we can see it. Cool. So the actual container for these images is only as tall as this, right? But you can see the images are overflowing the container. They should remain within this red container. At least that's how we want this to behave. So what we should do is we could make this minimum height of screen, and that way the container will still hold the images. And I think that's better already. You can see that the code snippet logo is not overlaid over the images that look kind of weird. And what else? What else should we do? Max height 7XL. Does that do us anything? So if I add back the min height screen, trying to think through this for a second. So basically what we're doing with that is we're saying this container should be the height of the screen. And you can see if I line up the red border, it's the height of the screen that I've I currently have here. And you can see it adjusts accordingly as I resize my screen. But when I resize my screen to be small like this and the images don't fit, what we want to happen is we want like some kind of scroll behavior. So I think what we can do is just overflow scroll using Tailwind. Very nice. So nothing overflows that container anymore, and it only will scroll the content accordingly. So that's pretty cool. So it's coming out nicely. The only other thing that's weird is like the actual like spacing is off. It's not. It should be like they look like staggered. They shouldn't be staggered like that. So let's see if we can dig in a little bit as to why that is. So height 96. Let's make our images a little bit smaller. I'm gonna make these a touch smaller, so like width and height 48. Okay, so it's still so I think it has to do with our space on the X and our space on the Y being inconsistent, but I could be wrong about that. Yeah, so see how this first one is still screwed up a little bit. Did I just not add that class to the first one? Is that why? No, they should have all the same classes. Okay, so it was something to do with those classes that I had there. So let's see if we can just figure it out, kind of work backwards. So if I add that here. Okay, so it has to do with these space X and space Y. Space without the X and Y, it will just imply that it's for both the X and Y axis. Space 4. That's interesting. So it doesn't space between space maybe I was wrong about that, and maybe we do have to pass the X and Y. I could have sworn that we didn't have to, but anyways, space Y4, whoops. Flex row. Do we get rid of the flex row? Okay. Flex space x4. It's interesting because it doesn't seem to be applying the same styles. Like we can see the spacing indicated by the orange that's around the outer edge there. And it doesn't apply that to the first item, which is interesting to me. One second. Okay, so let's see. All right, so what do we have here that is not being done on these other ones? Flex wrap, flex justify, overflow scroll, width of screen. So let's Google tailwind first item not using flex spacing. Space for first item not getting the space applied. ML4, try ML4, what? It's for putting space between items horizontally, so the intended use case is all your divs are on the same line. I see. Okay, so I have to add... Essentially, I have to add like a margin, it looks like, because it will only apply to the first... Or it will only apply to the inner items and not the outer. So presumably this last image is also not getting that same spacing, but is there a way we can like verify that? It looks like it is, but that's odd. Maybe it's just the first one that doesn't get the spacing. Okay, so that's weird, but anyways. All right, so oh, sorry, margin. We want padding. Okay, so I guess as opposed to doing it this way, what we could do is get rid of this the space that we're actually applying at the container level and apply spacing consistently to all of the image elements themselves. So what that would look like instead is we're just adding some margin. It would be like margin 4 to each item itself. And that way it's consistently applied. And so to do that, all we got to do here is add the M4 to this one spot. And let's get rid of the border that we're adding to debug. And let's get rid of these comments. Let's keep the images, but we're going to comment them out in case we need to come back to debug. No more images. Let's get rid of that border. And if we enter a prompt, Futuristic race car. Stick with it. Cool. A futuristic skyscraper. Very cool. Let's do a mansion by the ocean. Super cool. Awesome. So we have essentially built out a kind of a mock version, our own version of this DALL-E kind of example app that OpenAI provides on their website. We just built our own version of that. That was pretty cool. I didn't. So ultimately, I'll probably turn this into a blog post, but the last one that we did, it was already a blog post, and I built it out based off of that. But I think I'll convert something. I'll convert what we learned here today into a post itself, so others can refer back to it. But that was a lot of fun. I'll probably add a little extra polish to the blog post, but really this is all you need. You take a user's prompt and it gives you a really cool image, and auto-generated through the AI model. So I would say that's all for today. My name's Tim Wheeler. You can find me at timwheeler.com. My blog is codesnippet.io, and I'll throw that in here for just 1 second. So this is the chat API tutorial that I wrote up and I demoed yesterday. And today we were just messing around with the OpenAI chat API and built this really cool, the image API, OpenAI's image API. And we built a cool little app. So hope you guys enjoyed this stream, and I'll catch you around for the next one. Thanks a lot.